Okay, ladies and gentlemen, we're going to go back to chapter 3 a little bit and talk about some of the things that we have learned. So first, we use the formula y equals b times x minus h over a squared plus k. And that was our quadratic formula. With b, we learned did a vertical stretch, h was a horizontal translation, a was a horizontal stretch or shrink, and k was a vertical translation. So in going back, we're going to build on that a little bit more to talk about vertex form of a parabola, but we're going to work on a few things. So over here, the vertex of the parabola is its maximum point. So we just need to list the x and the y coordinates. So it's 3, comma, and then we look up here, it's 8. Then we have to list as a vertex of maximum or minimum. So we see this is the highest point. So this vertex is a maximum. What are the x-intercepts? X-intercepts are where it touches the x-axis. I can see it touches here at x equals 1 and x equals 5. So we have two x-intercepts, x equals 1, x equals 5. And then the y-coordinates of the x-intercept is always 0, because the x-axis is the line y equals 0. So how far was the graph stretched vertically? How far vertically do you have to get if you were to move vertically one point to get to the next point? So as we see, as I move over 1, I'm actually stretched 2. So we could see our vertical stretch here is 2. And then is there a vertical reflection? This was reflected over the x-axis. So yes, this is in fact a vertical reflection. So now to take this to vertex form. So again, let me rewrite vertex form. Writing things is a very strong way of learning them. So as I write down vertex form, and then I write y equals a times x minus h squared plus k. Again, a is our single vertical stretch or dilation, h is our horizontal translation, and k is our vertical translation. So putting in what we have from above, we know that y equals -2 because we had a reflection and a stretch times x minus, we had a horizontal translation of 3 for the vertex. So x minus 3, don't forget to square it. And then plus, I move the graph up 8, so plus 8. So in vertex form, this equation is y equals -2 times in parentheses x minus 3 squared, and then plus 8. Okay, in looking at factored form, again, it helps to rewrite factored form. So factored form is just when you have two factors written out, like x minus what's going to be our x-intercept times x minus our other x-intercept, written by an a, which is our vertical stretch or shrink, or vertical scale factor. So in remembering on here from the previous one, a is actually equal to -2. So y equals -2 times. In looking above, our two x-intercepts were x equals 1 and x equals 5. So we substitute 1 and 5 for R1 and R2. So x minus 1 times x minus 5. So if I write my two equations, y equals -2 times x minus 1 times x minus 5, we can actually convert these equations into general form, which is y equals ax squared plus bx plus c. So for general form, we have y equals ax squared plus bx plus c. So to change this equation, which is in vertex form, I see I have x minus 3 squared. So we have y equals -2 times x minus 3 times x minus 3 plus 8. Then I'm going to expand or distribute. So I'm going to leave the -2 in front. So -2 times x gives me x squared. X times -3 is -3x. And then I have another -3x, so that's -6x. And then -3 times -3 gives me +9. Closing the parentheses, and then I add 8. Now, order of operations says I need to distribute my -2. So y equals -2 x squared. And then -2 times -6 is plus 12x. -2 times 9 is -18, and then plus 8. Simplifying, -18 plus 8 makes a -10. So y equals -2x squared plus 12x minus 10. And simplifying the other one, we follow pretty much the same process. So I could distribute the -2 first and write that as y equals -2x, -2 times -1 would be plus 2. And then multiply that times x minus 5. So distributing again, -2 times x gives me -2x squared. -2 times -5 would be plus 10x. And then plus a 2x. And then minus 10. In adding all that together, we get y equals -2x squared plus 12x minus 10. And we see both of our forms, the vertex form and the factored form, give the same standard form. So in looking at example C for this problem, we had to write an equation in vertex form. So for question A, we have vertex form, and I always like to rewrite it. It's a powerful way of learning. So that's y equals a times x minus h squared plus k. And then I notice in this situation, if I look for a, my vertical scale factor, 1a is not negative because there is no reflection. And then as I move over 1, I move up 1, and there is no vertical stretch. So we know that a equals 1. And then h, the x coordinate of the vertex is 1. And k is -4. Substituting those in, we have y equals, if it's 1x, I can just leave that out. So x minus 1 squared, and then plus k would be -4. And then separately on here, in factored form, again, writing factored form, we know that we would have y equal to a times x minus r1 times x minus r2. And then we know that a is 1, so we can leave that out. So y equals x. Our first one is minus -1, so I can write +1. And then times our second x-intercept is x plus 3. So I plug in 3 for R2 and we in fact minus 3. So in factored form, we have x plus 1 times x minus 3. Now we need to show that both of these are equivalent and show an equivalent form of general form. So here if I have x minus 1 squared, I'm going to have y equals x minus 1 times x minus 1, and then minus 4. And then I start expanding. X times x is x squared. X times negative 1 is minus 1x. Negative 1 times x is minus another x. So minus 1x minus another 1x is minus 2x. And then negative 1 times negative 1 is plus 1. And then I still bring on my negative 4. So y is going to equal x squared minus 2x, and then 1 minus 4 is minus 3. If I expand factored form, I should get the same thing. So x times x gives me y equals x squared. X times negative 3 would be minus 3x. 1 times x would be plus x. 1 times negative 3 would be minus 3. Combining my like terms, negative 3 plus 1 gives me y equals x squared minus 2x minus 3. In looking at example A, we have to find the horizontal and vertical scale factors at the right with vertex 4 and negative 2, and rewrite it with a single scale factor. So in general form, we have y equals b, our vertical scale factor, times x minus h over a, our horizontal scale factor, plus k. So if we look at what our horizontal scale factor is, I notice the x coordinate moves from negative 2 to 7, or I'm sorry, from 4 to 7. So we move over 3. And then on the y-axis, I move from negative 2 to 4, and that's going up 6. So we can see here that b, our vertical scale factor, and is 6, and our horizontal scale factor a equals 3. And then I also know from the problem h is 4 because the x coordinate of the vertex is 4, and k is negative 2. So what I'm going to do is first plug in all my numbers. So y equals, instead of b, I write 6 times x minus, and h is 4, over a is 3, and I square that, and then I add on 4. Now, our goal here is to remove 3 on the bottom. So what I'm going to do here is get rid of my parentheses and put parentheses around both parts. Now, if I'm squaring the entire expression, I square the numerator and I square the denominator. So 3 squared gives me 9. So I have y equals 6 times x minus 4 squared over 3 squared is 9, and then plus 4. So in the numerator, I'm multiplying by 6, and then the denominator, I'm dividing by 9. So my single scale factor is 6 over 9. So my overall equation is y equals 6 over 9 times x minus 4 squared. Oh, and then the k was minus 2. I wrote positive 4. Let me just adjust that. So minus 2, and then minus 2. So now we look, the x-coordinate of the x-intercepts are also called the zeros of the graph. And we're going to look at the zero product property, which just says if a times b equals 0, then either a equals 0 or b equals 0. So in this equation, we have negative 1.4 times x minus 5.6 times x plus 3.1. Well, in doing that, in finding the zeros, I know that I want y equal to 0. So we have the equation 0 equals negative 1.4 times x minus 5.6 times x plus 3.1. Now in this multiplication, we can assume negative 1.4 equals 0 is a possibility. That doesn't make sense, so we're not going to examine that. Or we're going to look at x minus 5.6. That could equal 0. So we have that equation, x minus 5.6 equals 0. Or we could have x plus 3.1 equals 0. And then if I add 5.6 to both sides, we have x equals 5.6. And then here, subtracting 3.1, we would have x equals negative 3.1. So the solutions to this equation, which zeros are also called roots, are x equals 5.6 and x equals negative 3.1.